Good morning to all of you. Now, today I think we have the last class before this actual physical classes which will commence whenever the dates will be given to you, where you will be coming to your respective centers where you have taken on admission. So, yesterday we were seeing the basics of vectors, and today also we will be seeing some more conceptual introductory parts of vectors and what all we should know in advance before the main classes start. So you have seen we have dealt with calculus concepts, we have dealt with coordinate geometry, finding slope, equation of line and all. Then we had seen different curves, what are their uses, then what is the use of differentiation and integration in kinematics, where we can relate acceleration, velocity, position, speed, etc. Good morning once again to those who have joined just now. So we are just having a review of what all we have done, and most importantly, apart from basic mathematical concepts, we should also be aware of vectors, because throughout physics, leaving a chapter or two, everywhere you will find vectors appearing. So what we should know, like I told yesterday, what are vector quantities, how we represent them, and for their representation we also make use of what is called as unit vectors. What are the internationally accepted unit vectors, that is I cap, j cap, k cap, how we write a vector along with a unit vector. Then towards the end of yesterday's class, we saw the concept of angle between two vectors. So vectors have this very important feature about them, that if you take any vector, suppose this pen is a vector, this is the head part, this is the tail part, without changing its magnitude, that is the length, and if you shift it anywhere in space parallel to itself, this direction you are keeping the same, you take it anywhere in space parallel to itself, the vector will remain unchanged. The vector will remain unchanged. You will not see any change, in its magnitude or direction. So again telling this thing, vector can be shifted parallel to itself, and if you shift it parallel to itself, there will be no change in its magnitude or direction. That means the vector will also remain unchanged. So once we know that, now let's see the next thing, what we call as addition of vectors. Now when we add vectors, then this sum that we get is called as the resultant or vector sum. The resultant or vector sum. So if you remember, when we saw about units, that time also I told that we have physical quantities which you can categorize into scalars and vectors, wherein I told that vectors, they obey some special rules of addition, subtraction and multiplication as well. Division is not defined for vectors, you cannot divide two vectors, that all we have seen. So when we are finding the sum or vector sum or resultant, we should be careful with few things. What is that? It is not always the algebraic sum. For example, if I have 10 Newton force, I have 5 Newton force. Two forces are going to act on a body. Or leave 10 Newton and 5 Newton, I am taking 10 Newton and 10 Newton. If I have two forces, suppose both are vectors, F1 and F2, both their magnitudes I am taking as 10 Newton each, and I have the convenience of applying these forces as per my wish on a body which is kept over here. So I have here just mentioned, the magnitude. I did not mention which direction I am going to apply the force. So when I want to find the vector sum of these two forces, which I will call as the net force or the resultant force, it will be the vector sum, F1 vector plus F2 vector, right? This will be called resultant of the forces. Now when I take resultant of the forces, it is not that it will come only as 20. It is not that it will only come as 20. So what happens if I apply in one situation both the forces in same direction? First case, then will you see that the net force will add directly, it will become 10 plus 10, which is 20. Now both forces are in same direction, so net force is also in the same direction, 20. But if you take the second case, if you apply F1 here and apply F2 here, what will you see? You will see that both forces will cancel out each other. So here, if you see net force, you will say, without knowing anything about vectors also, you can say clearly that these two forces will cancel each other because they are equal and opposite. So you will say 10 minus 10. So even though you are taking vector sum, then also the resultant force is coming out to be 0. It is getting subtracted. It becomes the difference of magnitudes. In first case it becomes the sum of magnitudes, in second case it becomes the difference of magnitudes. Now if you take another case, say third case, where you apply the forces, one force this side, one force this side. So obviously you will see, because of these forces, the body will not move either horizontally or vertically, it will move at some particular direction. So you will see net force will come this side. One force is pulling you right, one force is pulling you up. So you will see that the net force will be somewhat in this direction. Both are making it move, so it is going somewhat in this direction. Now when it is going somewhat in this direction, so here we can say, if I take the magnitude of net force in this case, it won't be equal to 10 plus 10 or 10 minus 10. It won't be equal. Means it is not equal here to the sum of magnitudes. Either you add the magnitudes of both forces, or it is also not equals to the difference of magnitude. Neither it is equal to sum of magnitude nor difference of magnitude. That means there should be some other value of the resultant force. So whenever we have vector quantities, if the direction between two vectors is not specified, we cannot tell that what will be the resultant exactly. So here, if we keep on changing the angle between two vectors, then what will happen? In that case, we can say that the resultant will keep on changing. Not only in magnitude, in direction as well. Here you see, first case the magnitude of the force was 20 and the force resultant was in the direction of two forces. Here you saw resultant became 0. In third case you saw that the resultant is not only in right or up, it is in some certain direction, which is neither along horizontal nor along vertical. So basically we should know what is the rule to be applied when we are seeing addition of vectors. I hope it is clear to all of you. So let's see what we mean by addition of vectors and how we can get something which is called as a triangle law of two vectors, right? And from there let us find a mathematical formula for addition and use the same for getting subtraction of two vectors also. So again I am making it clear, the net resultant force of F1 and F2 is not always equals to the sum of their magnitudes or difference of their magnitude. It can take lot many values. It depends on the angle also between the two forces. So this is applicable for all vectors. So how we get the resultant and what are the important key features, let's see. This one I am going to erase because this was just an example which I thought I should put so that at least you should have a brief idea of what we are going to do. Force is a vector quantity, so let's see how we add or subtract vectors. Okay. So now we will be into some serious stuff. So put the chat in inactive mode so that no one can chat anymore presently while we are discussing something. Some students who are not ready to maintain the dignity of the class, for them I am not going to lose mine. So better that just keep the chat inactive so that those who are sincere, at least a few also, if they are sincere, they will be able to understand what is being taught. So addition of vectors, resultant or vector sum. So first of all you should know, first point very important, the resultant or vector sum is always a vector quantity. So if you are taking vector sum of two or more vectors, the resultant or vector sum is always a vector quantity. Clear? If suppose I am vectorially adding two or more vectors, so if I take this as R vector, the sum total is R vector. I said it is always a vector quantity. Then if suppose R vector is equals to 0, suppose R vector comes 0, that is the vectors totally cancel, or we use the word balance each other. The vectors totally cancel or balance each other. Then you will say that, sir, we are getting 0. But I said that resultant is always a vector quantity. So in that case, R vector is given a special name. It is called 0 vector. So from now onwards, remember this definition. What is a 0 vector? 0 vector means its magnitude is 0. It does not have any direction. So it is actually the resultant of two or more vectors which simply cancel or balance each other completely. As simple as that. The definition, when we say that R vector is a 0 vector, that means it is a vector quantity and it has been obtained from some vector sum. Now each of the vectors, if they totally cancel each other, minimum 2 vectors you can add, if they cancel each other minimum 2 or more than 2, then in that case whatever resultant you are getting a 0. So that 0, since we have said that resultant is a vector quantity, so we are bound to give a name to that resultant also as a vector. So 0 vector or null vector, 0 vector or null vector. This is called as null vector. If we apply the concept of null vector or 0 vector in case of forces, if net force on a body is 0, force is also a vector, then we get what we call as the condition of equilibrium. Condition of equilibrium or Newton's first law. So when we null vector concept applies to forces acting on an object, that is net or resultant force, which is the sum of vector sum of two or more forces. If it is 0, it is called equilibrium. And what type of equilibrium, that also in detail we will be studying later in a chapter, Newton's law of motion. Presently I am just writing the name. Translational. It is called equilibrium condition for the object. So when you use the concept of null vector, that means if we have two or more forces which sum up to 0 vectorially, that means they are cancelling, just like the previous example I took, 10 Newton forward, 10 Newton backwards. So 0 was the net value. So that 0 is a null vector, and we say this condition as condition of equilibrium. Understood? So when we add vectors, we should know at least these points. Now, once we have written this, what next? How do we add them? How do we represent this addition geometrically? So for that, let's understand. In the beginning I told displacement. Now displacement is a vector quantity. What is displacement? You will say, sir, displacement is a vector quantity. And I also told that if I take any two points in space, suppose I name the points as A and B, then I asked also, if you remember when we started motion, distance and displacement, there I said that suppose I take any two points in space, how many displacements are possible in between these 2 points? So you said that, sir, only one displacement possible. Means what is that displacement? The straight line joining the initial and final point, that is the displacement. So that means whatever path you choose to go from first point to other, you can have infinite number of paths, but displacement will be only one. Distances will be as many, but displacements will be only one, which is the length of the straight line joining the initial and final point. So what important conclusion do we get from this point is that between 2 points, whatever path you follow, vectorially, displacement is vector, mind it, vectorially all the paths are same. Scalarly they are different, but vectorially all the paths are same. That means you have only one displacement. So addition of vectors, whenever I explain to students, I explain it in this way so that you need not be bothered about triangle law, I was taking direction like this or opposite. Any confusion can be removed. I will show you how. So between any 2 points, say I take the points A and B, all paths are vectorially same. That is, the resultant vector for all the paths or the vector sum will be equal to the displacement from A to B which I told yesterday, if you write vector between 2 points, you can call it as AP vector. So this will be the resultant for all paths. And I told yesterday that if you reverse the direction of any vector, you just put a minus sign. if you reverse the direction of any vector, you put a minus sign before it, and if you are not reversing, you will just use plus sign. So we have to remember that between any 2 points, vectorially all are same. So this one gives us a relation, geometrical interpretation of vectors. If I want to arrange them, how will I get resultant? Let's see now. Examples. Suppose I have, this is a vector and this is a point A, this is another vector B, and you reach a point B. Now, if I join these two and if I write this as C, suppose. Now, if you are asked, is there a relation between A, B and C, and is C the vector sum or what? Let's see. I have told resultant we are going to write as R vector. Now, let's see. Here, what we will do, if they are asking, relate A vector, B vector and C vector, you are going to see something very interesting. So, what I can write, suppose my choice, I select the point OB, means I have to go from O to B. I said vectorially all paths are same. So I have got two choice, one is direct, can you see here, one is direct path and other is indirect. So OB, indirect, you will go from O to A. So you have two, direct O to B or O to A and A to B. Can you write like this? Two options you have. If you go O to B, you are writing OB vector. Otherwise, you will first go O to A, so you will write OA vector plus AB vector. That's it. Means OB vector will become the resultant of OA and OB. Now just fill in the blanks type of case. What is OB vector? I have given the name C vector, O to B, can you see? So in place of OB vector, I will write C vector. Equals to, what is OA vector? You can see here, A vector. What is AB vector? You can see, B vector. That means we can say C becomes the resultant of A vector, or vector sum of A vector and B vector in this case. And this thing only in the language of physics is called triangle law of addition of two vectors. So when you want to find the resultant of two vectors, if one vector is arranged and where it ends, the other starts. Then if you draw a vector from the starting point of first vector to the terminus of the second vector, end point of second vector, that will be the resultant of these two, or vector sum of these two. This is what we call as triangle law of addition, because the figure is a triangle. So triangle law of vector addition, again repeating, is what? If you take two vectors A and B, give them names A and B. Now if you have given them names A and B, where A ends, start B from there. If you are seeing such a situation, then what we can say is the third side of the triangle, which starts from the origin of the first vector to the end point of the second vector, this will be the resultant or vector sum of A and B, and this is called as triangle law. Understood? Now here triangle law we directly got from this simple concept. This is very, very important. This is my personal preference to students who face difficulty in seeing whether A plus B, A minus B and so on. Then many students ask me one thing, which I will share over here explaining this, that sir, how we will understand that we have to find, means we will go from O to B only. I can to take other points also. I said that is the beauty of this method, that you are free to choose any point, any 2 points you like. You are free to choose any 2 points you like, and you can use the concept and you will get the same answer. Let me show you how. Alternately, suppose another student says that why not if we go from B to A. What happens if I go from B to A? If I go from B to A, then I have 2 paths again. Then one path B to A will be vectorially same as the indirect path B to A. You can also go from B to O and then from O to A. Can you go or not? One path you are going from B to A directly and one you are going from B to O to A. So you will say that if I go in this way, will I get this answer? Let me assure you, you are going to get. See how. So you will simply write direct path B to A means BA vector. And indirect path you will write, first I am going B to O, BO vector plus O to A, OA vector. Now, if I just fill the blanks, what is BA vector? Let's see. Yesterday I told AB vector is B vector. Can you see AB vector is B vector? AB vector is B vector. So if I reverse it, so I told yesterday just put a minus sign. So AB vector, see in the diagram, AB vector is B vector. So BA vector will be minus B vector. So in place of BA vector, can I write minus B vector? We'll say yes. Now comes BO. You will say, sir, OB vector is C vector. That means BO vector will be reverse of C vector. OB vector is C vector. So BO vector will be reverse of C vector. Means you will say, sir, I will put minus sign. Very good. Now comes OA vector. You will say, sir, OA vector, so I am seeing A vector only, no need of reversing. OA is A only. So I will write A. Good. Now our final step, minus C take it on that other side, left side, and minus B take on the right side. So are you able to see you are getting the same expression? So this concept not only limits itself to triangles, you can use it for 4, 5, 6, 7, 10, 1000, as many vectors you want. You can relate vectors and their vector sum or difference using this basic concept that as per your wish, not the wish of your parents or your friends or relatives or anyone, as per your wish, take any 2 points and all the paths that will take you from first point to other will be vectorially same. Just write the vector equation, you will get the relation between the vectors. I hope this point is also clear to everyone. If anyone has any doubt, you know very well that later you can go through the video and you can hear it again and again. So I am showing you, so this I told is triangle law of vector addition. Now I am showing you that what if I extend this idea to multiple vectors and can I get a relation between them or not, and what we can say about the magnitude of resultant of 2 vectors. That also triangle law, we will see how we use triangle law in getting the resultant of 2 vectors. So let's see. Second example, what I am taking is, so you will come to know that what is vector difference, that also will be clear to you. Second example I am taking, this is A vector, this is B vector, and this is C vector. Let's take names as PQR. Now here again what happens, students once they hear triangle law, they become very possessive with the law and they always say that, sir, C is equals to A plus B, that's it. don't commit that blunder that just randomly spill out that C is A plus B, because vector sum as well as vector difference both are possible in the same triangle. It depends on the alignment of the vectors. If you see the last example where I took A vector ends, there B vector starts, but in this example you are seeing I have shown A and B both are starting from the same point. They are starting from the same point. So C vector, is it a vector sum or is it something else, we want to know. So I told the simplest way what to do. I told the method, suppose I go for C vector, I can go C vector P2R. So I will just use my own method P2R. One is direct PR and one goes from P to Q and Q to R. That's it. So PR is equals to PQ plus QR. One direct path, one indirect path. Means go from one to other, which you have selected. Now fill the relation by putting the values. So PR I have named as C. What is PQ? Now you can see the arrow which I have marked over here. I have taken QP as A. See here, QP as A. So PQ will be minus A, reversed. Now QR you are seeing same direction, no need of reversing. What is it? B. Means in this example, instead of vector sum, you saw the same C vector which was earlier vector sum, now it became B minus A. So C becomes vector difference, which is called subtraction of vectors. It is called vector difference of B and A. If I extend this, and as I told, not only to, you can limitlessly use for as many vectors you wish. Suppose we have like this, and they have given me some names. We have taken different vectors over here. Write the vector relation between given vectors. So suppose I arrange these vectors in a polygon, as you can see in the diagram. Now as I told, be selective as per your own wish. Just take whatever points, 2 points you want to. So what I can do, suppose my wish that suppose I select a point R2S. We have selected this. Then I will write one is direct RS, one is direct RS, and the other will be going opposite. So R to Q, then Q to P. I told there is no boundation that you have to use RS only. You can take any point and whichever direction you want. It is totally up to you. You will always get same answer. RS equals to RQ plus QP. Then from P you have to go to V. Then from V you have to come to U. Just like you are going from one place to other, many a times you prefer a different path. But both paths, suppose there is a shortcut, there is a long cut or long route. By any you will attend, means start from the same point. Suppose you are home and you are going your school. There are two paths. So both paths are parallel. Whichever path you follow, you will reach to your school only. So same here. You are starting from R, you are reaching S. One you are taking direct path, one is the longer path. But both will be vectorially same. So RQ plus QP plus PV. And why I am saying vectorially same again and again? Because between 2 points there is only one displacement possible, and displacement is a vector quantity. You can have infinite distances, but displacement is only one. So every path is vectorially same. That's why I am adding vectors. So VU plus you have UT, still you have not reached. From T you will come to S. So finally I reached S. Now comes the final part, just fill. RS I have marked as D. Now I am seeing RQ. RQ is opposite to me. QR is given as C. RQ is reverse of C, means minus C. Plus QP. QP is what? B vector. Plus PV. PV you can see is opposite of A vector, minus A vector. Plus VU is G vector. UT minus F vector. And TS plus E vector. So that means if I take the minus on one side and plus on one side, so you will see A vector plus C vector plus F vector, they go in left hand side, and we have D also, A, C, D and F, and rest on the right hand side you have B vector plus G vector plus E vector. So this is the vector equation which is relating these vectors. That means A plus C plus D plus F is balancing B plus G plus E. So when we wish to write vector sum or vector difference, if a geometrical representation is known to us, then this is how we can write. And we take the side of that geometrical representation as the magnitude of the given vector. For example, RS vector magnitude means length of the straight line RS will be the magnitude of D vector. If you take the length of the straight line RQ, it will be magnitude of C vector or minus C vector. When you take magnitude of the straight line QP, you get the magnitude of B vector, and so on. I hope this is also clear. So once we know this, now finally we know how to write the resultant vectorially, and how we take angle between two vectors which we studied yesterday. Combining both, we will now come to see what is the magnitude of the resultant and its direction if we have two vectors by using triangle law. Now suppose we have a vector A and we have a vector B. Their angle by joining their tails is theta. The magnitude of A vector, let's take it as A, and the magnitude of B vector, let's take it as B. So what we are doing is to find the resultant. Now see, as I told yesterday and today in the beginning also, you can take a vector and you can shift it wherever you want, parallel to itself, there will be no harm. So if I redraw the diagram, this is a vector, just see how I am redrawing it. This was B vector. Now I can shift this B vector here also. I can do so. I told na, you can lift a vector and keep it parallel to itself. I have shifted it. So I have shifted to new position. Now once I shift, let's mark this point as O and this point as A, and this is our B vector, this is also B vector. Let's call this point as B. So this angle was given as theta, so this angle will be also theta. This angle was theta, so this will be also theta. I have shifted it parallel. Now I told by triangle law, if this is a vector, where it ends, this is B vector. So if I join these two by a straight line, this will be only called as the resultant, which I will write A vector plus B vector by triangle law. I told now where A first ends, other starts. Then from beginning of first to end of last, you can say this is the resultant. Means the side OB will give you resultant. Acha, A and B have an angle theta between them. Resultant is also making some angle with A. Let's call this angle as phi. So I am going to write the data here. Magnitude of the resultant is nothing but the magnitude of resultant of A and B, which is nothing but the side OB. The length OB of the triangle will give you resultant. Okay, and let resultant vector makes, I have marked this angle as phi, with which vector? A vector. Again you will say, sir, angle to we take between tails. You can see, yes, tails I have taken. So it is phi. A vector and R vector tails are making angle phi. So these two I have to find. How? Let's see. For that we make a small construction. See what is the construction we are making. Now this side OB I have to find, which I said is the magnitude of R vector. This length we know is A. This angle is phi. And by producing we saw, if total angle was theta, if total angle between the two vectors was theta, so this will be also theta. What is AB? If you see AB is the magnitude of B vector. AB is the magnitude of B vector. Let's call it as B. So we make a small construction. We just drop a perpendicular as per our wish. And let's call this point as C. We just drop a perpendicular and call this as C. This is my wish. Now once I do that, by trigonometry you know sin theta will be BC by B. So can I write B sin theta? Sin theta is perpendicular by hypotenuse. So perpendicular will be hypotenuse into sin theta. So it becomes B sin theta. Now cos theta is base by hypotenuse. So cos theta being base by hypotenuse, so base will become hypotenuse into cos theta. So what was the use of this construction? The use of this construction is only that now I will easily get the value of the resultant. So R vector magnitude, which is OB, is nothing but, by Pythagoras theorem, can I write it is under root of OC square plus BC square. OC square BC square, right angle triangle. So now if you substitute OC is A plus b cos theta whole squared. BC is p sin theta whole squared. So from here we get the vector sum magnitude, the magnitude of a vector plus b vector will have a very important formula. Let's see what we are getting. First time you will get a square plus b square cos square theta plus b square sin square theta. Second time I will repeat, b square cos square theta plus b square sin square theta. Take b square common, so cos square plus sin square will become 1. So you get b square. Third term you will get from this square is 2ab cos theta. So this is our required formula when we have two vectors and I know the magnitude of each vector. I know the magnitude of each vector a and b, and the angle between the two vectors by joining their tails is theta. Then the resultant vector sum will be equal to under root of a square plus b square plus 2ab cos theta. This is the case. And we had to find one more value, which is how much angle, because direction is given by angle. How much angle r vector is making with a vector, I have assumed that angle as phi. So if you use a bit of trigonometry, so you can apply tan value to the right angle triangle. If you see the big right angle triangle, tan phi is perpendicular by base. Perpendicular BC by base, which is OC. So if you put, so you get an expression for tan phi, BC will become b sin theta by a plus b cos theta. So this formula gives us the angle that the resultant makes with a vector, and this formula gives the magnitude of the resultant. So I hope these two formulas are clear to all of you. I'll take an example and I will show you by screenshot you can take presently, so that when we are dealing that question you are understanding how we are taking the values. So a square plus b square plus 2ab under root, this is the magnitude of a plus b, a vector plus b vector, and tan phi is b sin theta by a plus b cos theta. So I hope you have taken a screenshot, and now let's take an example of this. So angle between A and B is 60 degree. So we can say R vector magnitude, which is the magnitude of A vector plus B vector, is equals to under root of A squared plus B squared plus 2AB cos 6 theta. A is given to us as 4 unit, B is given to us as 2 unit, theta is given to us as 60 degree. So just putting the value, 4 4s are 16, 4, 2 into 4 2s are 8, cos 60 is 1 by 2, power में 1 by 2, 2 cancels. So we have 20 plus 8, 28 root 28 can be written as 7 4s are 28. So 4 will come outside the root, it will become 2, inside you will have root 7. So 2 root 7 units is the resultant. And if the resultant makes an angle phi with a vector, whereas A and B, the angle they have given us theta 60 degree, we are asked how much angle resultant makes with A. Tan phi B sin theta by A plus B cos theta. So here putting the value of B 2 sin 60, A again is 4 plus 2 cos 60. So you will write sin 60 root 3 by 2, 2 cancels, root 3. Cos 60 1 by 2 cancels, so 4 plus 1, 5. Tan phi is root 3 by 5. When you don't know any value, there is a mathematical way of writing. We simply write, if tan phi is root 3 by 5, there is a mathematical way which we call as inverse. We will simply show it like this, tan to the power minus 1, tan inverse of root 3 by 5. You can end your answer in this particular way. So resultant has a magnitude of 2 root 7 units and it is making phi is equals to tan inverse root 3 by 5 angle with which vector? A vector. Is it clear? So I will end the class with 2-3 important quick notes. The magnitude of resultant of two vectors is a square plus b square plus 2ab cos theta. Now therefore, number 1, maximum resultant, if you want, all the terms are constant except for theta, is when this term will become maximum. Now all are getting added, so maximum is when cos theta is maximum. Cos theta maximum, you know, is 1. That is theta is equals to 0 degree. So when theta is 0 degree, that is the vectors are in same direction, parallel to each other. When vectors are in same direction, I took the first example in class today, 10 Newton, 10 Newton, 20 Newton force got added. They were in same direction, theta is 0. So cos 0 will become 1. So the maximum resultant is how much? Under root of a square plus b square plus 2ab, which is nothing but a plus b. So you will directly add the magnitudes. So maximum resultant of two vectors is simply the sum of their magnitudes and when the vectors are parallel to each other. Means you will see if this is a vector, b vector, both are in same direction. You can directly add their magnitudes. Second comes minimum magnitude, is when cos theta is minimum. Now here students make a mistake that sir cos theta minimum means 0. No, cos theta minimum value is minus 1. So if you take minus 1, then R min will become under root of a square plus b square minus 2ab, which can be either written as a minus b or b minus a, whichever is bigger minus smaller. Minus 1 is, we know, when theta is 180 degree. So we write theta equals to 180 degree, means the vectors are opposite. So if you have one vector this side and one vector on the other side, then only you will have angle between them 180. So the least value of resultant of two vectors is simply the vector difference of their magnitude, a minus b or b minus a, which is bigger minus smaller. And the maximum value when you take of two vectors resultant, it is a plus b. So if you see two vectors are given, they will say one has a magnitude 5 and one has a magnitude 3. They will say the resultant of these two vectors whose magnitude are 5 and 3, what is the range of values they can have? So I will say the maximum value they can have for the resultant is 5 plus 3, 8. And the minimum value they can have is 5 minus 3, that is 2. So the resultant can take all values from where to where? 2 to 8. Understood? So the resultant will lie in between a vector and b vector. Resultant will lie in between a minus b and a plus b, or b minus a and a plus b, depending. This one I am telling many times that when you are taking a difference, bigger value minus smaller value, that is to be kept in mind. So I hope this class also, whatever we discussed, the standard points, how to take the vector sum and all, geometrically, what is the expression for this vector sum, magnitude and direction using triangle law, everything is clear to all of you. So here we are ending the class, and after this you will be having your chemistry class in continuation, which I think that many are eagerly waiting for. So this is, we are ending the class of vectors. So when we meet, wherever you go to, whichever center you go, everything will be taught again, so you need not have worries about that. But as I said yesterday also, repeating myself again, that these concepts, these will serve to be providing you with extra advantage compared to the students who have not gone through these basics. So when you will be studying that particular chapter, you will feel that, oh yes, now I can understand it easily. But for that, be sincere, that's what I can wish for all of you. Okay, so that will be all. Have a great day. Thank you. And if you like the video, you can ask your friends also to go through the video, view the channel and subscribe to it. Thank you.